Today's topic is very most important topic, that is Lami's theorem. Now what is Lami's theorem? Whenever on a particle or on an object three coplanar concurrent forces are acting simultaneously, but then also the body remains in equilibrium, means the system is in equilibrium under the action of three concurrent forces, then the Lami's theorem is applicable. And what is the use of Lami's theorem? When on a body three forces are applied, out of these three forces any two forces is available to you and all the angles in between the forces are known to you, then you can find third unknown force. This is the main and important use of Lami's theorem. Let us discuss. This Lami's theorem has been asked in the GTU exam frequently. Here it is written that GTU June 2010, January 2016, May 2017, but actually it has been asked several times in the GTU numericals, GTU theory exams. Now let us see what is given in the statement. If three coplanar forces acting at a point be in equilibrium, means you can see in the figure that this is the point O. Out of from point O, outward forces are P, Q and R. These three forces are in equilibrium and the angle between the forces are alpha, beta and gamma as shown in the figure respectively. Then what happens? Each force is proportional to the sine of angle. Sine of angle means sine theta, cos theta, like this. So sine of angle between the other two. Means what? If you are taking the force P, then what is the opposite angle of force P? It is alpha. So P upon sine alpha, it is the first term. What is the next force? Q. Then the opposite force will be beta. Then the second term will be Q upon sine beta. And third one is similarly R upon sine gamma. These all are equal because they are in proportion. So our target is to determine the equation like P upon sine alpha is equal to Q upon sine beta is equal to R upon sine gamma. This equation we have to prove. Okay, so just remember this equation. In this equation, P, Q and R are three forces. P, Q and R are three forces, different forces. R is not the resultant of P and Q in this case. Okay, so P, Q and R, all the forces are very different, very individual, not dependent on each and other. Okay, let us start the proof of this equation. P upon sine alpha is equal to Q upon sine beta is equal to R upon sine gamma. Let us start the proof. You can see the modified figure over here. You can see this is the force P, this is the force Q, and third one is the force R over here. Now this force R can be extended over this vertical line and the direction will remain same in downward direction. Now angles. Now concentrate on the angles carefully. This angle, total angle is gamma. This total angle is alpha and this total angle is beta. So by summation you will get alpha plus beta plus gamma is equal to 360. As you know, these three angles are completing the circle. So alpha plus beta plus gamma is equal to 360. Now, for this vertical red line, you can see this angle is beta. This angle is beta. So the upward angle, this upper angle is 180 minus beta because the straight line is of 180. Similarly, on the left side, the lower angle is alpha. You can see, let us change the color. You can see this angle is alpha. So the upward angle is 180 minus alpha. So this angle is 180 minus alpha and this angle is 180 minus beta. So this is the game of angles actually. Now, as per the definition or as per the property of the law of parallelogram of forces, you may know that this line, let us check, this line and this opposite line both are parallel to each other. So they are forming the pair of corresponding angles. Which corresponding angles? Like this, Z formation will be there like this. So this is Z forming. So this angle included in the Z, this angle and this angle both are equal. So this is 180 minus beta. So here it is also 180 minus beta. Similarly, the reverse Z is also possible, like this. Starting from point A, this red line, this vertical line, and this red line are forming Z. So in the Z, 180 minus alpha, 180 minus alpha, these two angles are equal. So they are pair of corresponding angles. Okay, so corresponding angles are always equal. So what is our target? Our target is to determine the angles in the triangle. Which triangle? OAC. You can find out from the figure that what is the triangle OAC. Here it is point O. You can see here it is point O, here it is point A, and here it is point C. So in the triangle OAC, the two angles are ready now, 180 minus beta and 180 minus alpha from the geometry of the figure. What is given in the construction? Consider three forces P, Q and R acting at a point O. That opposite angles of the forces are alpha, beta and gamma as discussed earlier. Now draw the lines OA equal to force P and OB equal to force Q to some scale meeting at point O. It is just for the formality. Now complete the parallelogram OACB with O and OB as two adjacent sides and OC as a diagonal. Means you have to complete this parallelogram. From the figure, it is clear that OB, C and A is the parallelogram. So complete this parallelogram, but out of this parallelogram, only one triangle is important. That triangle is OAC. Let us go ahead. Must remember that what we have to prove. We have to prove P upon sin alpha is equal to Q upon sin beta is equal to R upon sin gamma. This Lami's theorem we have to prove. Let us go ahead. So same figure will be there in triangle OAC. According to the sine rule, this line is OA. Okay. Consider on the triangle only, not on the parallelogram, on the triangle only. This is the line OA. So opposite angle of the line OA will be 180 minus alpha. So as per the sine rule, OA upon sine angle ACO. Sine angle ACO. Okay. So this is the sine rule. Side divided by opposite angle in terms of sine, not cos. The second line, or you can see the second side will be CA. Then the opposite angle of CA will be 180 minus beta. So here it is the equation CA upon sine angle COA. You can see COA. So here it is the opposite angle of CA. The last one is OC upon something. So here you can see OC. OC. So the opposite angle will be this. But this angle, opposite angle is not available. The name is available only, which is CAO, or you can say OAC. So OAC will be equation number 1. So hence this is the equation number 1. But what is our difficulty? We are knowing that the first angle ACO, which is 180 minus alpha from the figure, the second angle COA, which is 180 minus beta, which is also clear from the figure, but the third angle sine OAC is not available to us. So let us find OAC first. Now as per the rule in this triangle OAC, other two angles, these two angles can be subtracted from 180 because the addition of all the three angles in the triangle is 180. We are knowing this. So 180 minus first angle ACO, which is available here, second angle COA, which is available here. So just replace the values. So 180 minus ACO means 180 minus alpha. Here it is minus. Okay. And minus COA is 180 minus beta. So just removing the bracket, you will get minus 180 plus alpha and minus 180 plus beta. So 180 will be cancelled out. Alpha plus beta minus 180 is the final equation. Now, as we have discussed earlier, alpha plus beta can be replaced by 360 minus gamma. Because alpha plus beta plus gamma, the total is 360, they are forming circle. So in place of alpha plus beta, we can replace 360 minus gamma and this minus 180 will remain as it is. So 360 minus 180 will be 180 minus gamma. So this is the angle OAC is equal to 180 minus gamma. So angle OAC is equal to 180 minus gamma finally. So the third angle, this angle is now available, which is angle OAC is equal to 180 minus gamma. So what we have done right now, we have just found out three different angles of the triangle. to use in equation number 1. Now all these three angles will be replaced in equation number 1 with the help of forces. Let us see ahead. The same figure is continued. You can see the equation number 1 is now becoming OA, CA and OC. So the sides are as it is, but the angles are replaced by the values 180 minus alpha, 180 minus beta and 180 minus gamma. Means just opposite angles of OA, CA and OC. What is opposite angle of OA? You can remember this. OA is this side. Opposite angle will be 180 minus gamma alpha. So here it is. CA will be this side. So opposite angle will be 180 minus beta right here. And the third one is OC. The opposite angle will be unknown, which we have calculated 180 minus gamma. Now what is sine 180 minus? You must remember that as per the theory, the quadrants. So what is the meaning of this quadrants? In the 11th, 12th standard or in the 10th standard, you may study all STC rule. All STC. Here it is 0, here it is 90 and here it is 180 and here it is 270 degree angle. So 180 minus means you have to go reverse in the second quadrant. So in the second quadrant, sign is always positive. So from this equation 180 minus alpha will now becoming sine 180 minus alpha equal to sine alpha. Similarly, sine 180 minus beta equal to sine beta and similarly sine 180 minus gamma is equal to sine gamma. So hence the sine 180 minus alpha, 180 minus beta, 180 minus gamma is converted into sine alpha, sine beta and sine gamma only. Now what is OA, C and OC? From the figure you can see this force OA will be equal to P. The second side OC will be equal to R and the third side CA will be equal to Q. So just replace the forces OA equal to P, CA equal to Q and OC equal to R. So our final and last equation is P upon sine alpha is equal to Q upon sine beta is equal to R upon sine gamma. So friends, this is the Lamis theorem, which is very complicated and very tough to remember. So just practice at your own. And now in the next lecture we will start the numericals based on Lamis theorem. You must remember that this theorem and the sums based on this are very difficult. For this I will give you some rules and regulations to calculate, to solve the numericals. Remember that you must be familiar with the geometry of the figure, means corresponding angles, vertically opposite angles, addition of three angles of triangles are 180. Then after some corresponding angles, vertically opposite angles, linear pair, all the pairs of the angles are known to you. Then after areas, volumes, trigonometries, sine equal to opposite upon hypotenuse, cos equal to adjacent upon hypotenuse, tan equal to opposite upon adjacent. This type of trigonometric functions are also known to you. So this is the basic requirement while solving the Lamis theorem numericals. So stay tuned and we will start Lamis theorem numericals in the next lecture. So till then you must remember this Lamis theorem, repeat this video again and again and solve your doubts with the help of this video. So Lamis theorem is very important from the exam point of view. Just solve this at any cost. We will start numerical in the next lecture. Thank you very much, students.